Hi there, this is Thomas from Investment Excel. Today I will show you the normal distribution and how it's built in terms of parameters. I will use simulation to show the statistical properties of the distribution and also look at some statistical inference. It's a topic, I would say, on a basic level, at least for the most part of it, but there are some reference to the central limit theorem that could be challenging. If you're not too familiar with the central limit theorem and the normal distribution, I refer to other sessions I have made on Investment Excel. This video and the Excel workbook are both available on the homepage of investmentexcel.com and spotify.com. Let's move on. Look at the normal distribution and just start here because this is the view that everyone knows. This is the classical bell-shaped form, 50% area to the left of the average, in this case 1000, and 50% on the other side. Now the normal distribution is a parametric functionality. That means it's a continuous relationship between what we call on the y-axis the density and on the x-axis the outcome of the stochastic variable. The stochastic variable x, as we most often labels it, is governed by a statistical distribution or model, which is the normal distribution. So you can go in and see, okay, what is the density of getting 1050, 950, and so on. What we know from the normal distribution is that the highest density is associated always with the mean, the center of the distribution. If you might note, or if you note here that this doesn't look continuous, it's just because of the way that I have graphed it in terms of a scatter plot. Never mind. Okay, let's look at a concrete example. I have a true population where it's assumed that the weekly dollar income in the US is 1000 and it has a standard deviation of $25. So a normal distribution that describes the entire US population just from two parameters of a mean and a standard deviation. And this is exactly the distribution that I have here. And here we can actually identify already the 95% confidence interval. Why? It's because we know that a 95% confidence interval is a 2 standard deviation away from the mean in both directions. And as I have 25 as the standard deviation is $50 in each direction from the mean. So 950 and 1050. So this interval here is a 95% confidence interval. 95% of all incomes, all registered incomes in the population is within 950 and 1050. Down here we have the cumulative